Okay, so we're back, chapter 4. This is section 4.2, and I called this part 1 of linear relations. And really what I want to show you is how you can graph now a linear relation using a table of values. So we're going to graph. But before I actually start graphing, let's just do a quick review to make sure that you guys got this stuff from before. Who came up with the idea of graphing? Well, there's a legend that says that there was a sick boy who was lying in bed at home. He noticed a fly landing at different spots on the ceiling. Yeah, he was pretty bored. To determine if the fly ever stopped at the same spot twice, he developed something called the coordinate system. So, coordinate system. By doing what? By drawing lines on his ceiling. And from there, he could figure out the exact spots the fly had stopped. Now, how did he create this coordinate system? Well, he created it by forming by putting two lines together and intersecting them. So you can see these ones right here. Okay. One of them is called the horizontal or x-axis. There we go. One is the vertical called the y-axis. And each axis is split into two parts, a positive and negative side. The two lines meet at a particular point in the middle, which he called it the origin. And two lines break up the graph into four spots or four regions called quadrants. So let me show you which one is quadrant number 1. It's actually over here, quadrant number 1. And I'll use Roman numerals. So that's a 1. Quadrant number 2 is over here. So if you don't like Roman numerals, 1, 2. Quadrant 3 is down here, 1, 2, 3, and quadrant 4, Roman numeral 4 is IV, and that's number 4. Okay, so quadrants, quad means four different areas. So, to be able to describe the position, the boy came up with something called an ordered pair. And ordered pairs are listed like brackets here, bracket with this x value as the first number with a comma, and then y as the second number. And this shows the distance from the point of the origin. Okay. So to graph, we use these ordered pairs, also known as coordinates, to move the appropriate way. That first number, which is the x, okay, moves either right or left. You move right when the answer is positive. You move left when that x value is negative. The second number, which is the y, moves the coordinate in the y direction, which is up or down. And so if it's positive, it goes up, and if it's down, it'll be negative. So, as example number 1 underneath, I just want you to plot these points to make sure we can actually use the coordinate grid properly. So I'll plot 1 or 2 of them, and then I want you to try the next on your own. 1, 6 is the point A, so starting at the origin, our first number represents 1, going 1 to the right. So here we are. But we need to then go 6 which way? The next number 6 is the up or down. Because 6 is positive, we go up. So here is the point A. Okay, that's 1, 6. Let's try B together. Okay, B says 3, 5. So the 3 here means 3 to the right. So starting at the origin, go 3 to the right. And then negative 5 means 5 down. So we'll go from 3 now 5 down. Bam, there's point B. I'll do one more and then you do the rest. C is negative 6, 2. So that negative 6 means you go 6 to the left, starting from the origin. Whoop. And then the 2 means you go 2 up. So 2 up, whoop, right there. Alright, I've done enough examples. You now try the rest. Go. Negative 8, negative 7. Down here. Whoop. D. Interesting. This one's 0. So 0 right, 0 left. You just don't move right or left. And just go 5 up. Whoop. And there is E. Negative 9, 0 means you go negative 9 to the left, but don't go up or down, so you're on the horizontal axis. And then G, 10, negative 10. That's way down in this bottom right corner. Did you get them right? Cool, cool. Let's move on. What if I now switched it up for you? Let me give you the point. Now you give me the ordered pair or the coordinate. And once we get this, now we're ready to learn what we need to do today in section 4.2. So A seems to be here. Measuring from the origin, I went 5 to the left, so negative 5. And then it looks like I went 3 down, so that'll be minus 3. Let's do B. B looks like it's over here, so 2 to the right, 2, and then 2 down. So you always go horizontal first, and then the second number is vertical. You try the rest, please, and then come back and check your answers with mine. Are we good? Alright, so now the main event. Here's what I want you to learn today. Hey, we had a question like this before. Determine an equation that relates the number of dark squares to the figure number. It's not the entire number of squares, but just the dark squares. And so once again, last day we learned how to describe it in many ways, in words, a table, equation. And now today I want to show it to you visually as a graph. So I've got here this chart. Let's fill in the chart first of all. Let's give it a title for our two things we're comparing. We're comparing the figure number. Maybe I'll use the letter N for that. And you're comparing this to the number of dark squares. And how about I'll use the letter D. Okay. So in figure number 1, how many dark squares do we have? 1, 2, 3, 4, 5, 6, 7, 8. Figure number 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Figure number 3 seems to be 16. And I'm going to leave the last row as our variable n. Okay. Now here I did not extend the chart for you, but I gave you some space to describe the patterns. Okay. Let's see what the pattern is here. So as the figure number increases by 1 every single time, what happens to the number of dark squares? If you said it increases by 4, I like it. So our pattern begins with the number 4. Now remember, we're going to multiply this by some variable, and in this case that variable represented by the figure number. So for each of the rows I'm going to use the corresponding figure number. There's 1, there's 2, there's 3, and the hardest part is to find that magic number that we have to add or subtract to get our dark square value. So in this particular first row, let's take a look. 4 times 1 is 4. 4 plus what gives you 8? I heard someone say 4. Okay. Let's try the next row and let's see if it's okay. Let's see if 4 still works. I've got 12. I've got 4 times 2. That's 8. 8 plus what gives you 12? I heard someone say 4 again. Yay! And I think this works as well. So what is our lovely pattern here? And how can I write an expression for the number of dark squares? It's 4. And that 1, 2, 3 just becomes my n value. And it's 4n plus 4. So our equation here is D equals to 4n plus 4. And let's label our variables here. D equals the dark squares, and n equals the figure number. Alright, so all that is a review up to here is a review from last day. Let's turn the page, and now I'm going to say, hey, can you list the ordered pair? So we're going to use our table again, and can you now look at each row and create an ordered pair? So what I want you to do is that 1 and 8, I can write that as 1 comma 8. Let's go back again. How about the next row? 2 and 12. So let's write that as an ordered pair. And then finally, I think we had one more. I think it was 3 and 16. So now we change the table into an ordered pair. Okay. Now, it's time to graph. So here's our ordered pairs, our coordinates. That's great. So let's draw our axes first of all. Maybe I'll draw my axes right here. Whee! There's my vertical. and then maybe my horizontal could be here. Okay. Now we can call this x or y, but better yet, let's actually use the variables that we were looking at, which is the figure number and the dark square. So first coordinate was the figure number. That always goes on the horizontal. So I'll call this n now, the figure number. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on the vertical, we're going to use the dark squares. So I'm going to write down dark squares. Gotta label things so people know what we're talking about. And let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Woo! Just enough, I think. And let's go ahead now and plot these points. So our first point was what again? I totally forgot. Oh, 1, 8. So from the origin, that's right here, we're going to go 1 to the right and then 8 up. So here's our first point, 1, 8. Our next one was 2. So from the origin, 2 to the right and then now up, I think, until 12. And our third coordinate, 3, 16. So 3 to the right, up to 16. And those are our 3 points. Okay. Now, of course, we can do more, but our charts and our ordered pairs only had 3, so we'll just leave it with 3. And I want to just finish the blanks here. It says, in this example, we say the number of squares, or the dark squares, depends on the figure number. Oops, why is there 2 to use? Get rid of that one. We call squares the dependent variable because it depends on the figure number. And we plot the dependent variable on the vertical axis, always. You might have seen this in science as well, or even last year in grade 8 math. The independent variable in this case is the figure number, and that is plotted on the horizontal axes. And when the two variables are related to each other and form a line, so if you can see my graph here, if I were to connect dots, I'm not asking you to, but if I were, can you see how they kind of lie on the line? Yeah. So if they lie on a line like that, we have a special name for that too. We call this a linear equation or relation. Okay, and that's why, remember last video in 4.1 I talked about this as a linear pattern. Now you can visually see why this is a linear pattern, because all the coordinates that we created lie on the same line.